In this problem, we're asked to take the waveform on the left, time delay at 1 second, to get the waveform on the right. Then we want to compute the exponential Fourier coefficients for the waveform on the right and show that they differ from the coefficients of the waveform on the left by an angle of n times 180. So if we look at the waveform on the left, they're the exponential Fourier series coefficients. Okay, C0 is 1/2. There's a C sub n. So now if we look at our waveform on the right and go in to calculate C0, C0 is 1 over T0, integral from T1 to T1 plus T0 V2 of T dt. So the C0 again is 1/2, because T0 is 2, and that's the, and what we're going to do, since the T0 is 2, I'm going to integrate. I'm going to start and go from -1 to 1. So we've got the integral from -1 to 0 of 1 dt. Okay, so we integrate that, we get 1/2 times t, evaluate from -1 to 0, and we get 1/2. Okay, so the average value doesn't change, and we wouldn't expect it to. Okay, we wouldn't expect it to. This is the same waveform shifted here. We didn't move the waveform up or down, so this waveform should have the same average value. Now let's calculate the C sub n. Okay, so the C sub n, 1 over T0, and go from T1 to T1 plus T0 V2 of T e to the minus j n omega naught t dt. And we know omega naught here is 2 pi over T0, and we know T0 is 2, so we have 2 pi over 2, or pi radians per second. So now we have 1 over 2, integral from -1 to 0. The function v2 has a value of 1 from -1 to 0. So we have the integral e to the minus j n pi t dt. So integrating, we get 1/2, and we'll get 1 over minus j n pi. And we'll have e to the minus j n pi t evaluated from -1 to 0. So now we get 1 over minus j2 n pi. We have e to the 0 minus e to the minus j n pi. And we have 1 over minus j2 n pi. We have 1 minus e to the minus j n pi. And we can take one more step. We can pull this j n pi in here and leave the negative out front. So our C sub n's will become minus 1 minus e to the minus j n pi over j2 pi n. And if we look at the C sub n's for our original waveform, notice we have the same thing, we just don't have the minus sign out front. So if we take this waveform and shift it 1 second, the sign on the C sub n's change. So for this waveform, we have a plus here. We shift this waveform over, we have a minus, thus demonstrating that delay will give us a negative sign.